Starting now. Chapter 5.4, Divide Radical Expressions. The rule for dividing radical expressions is, you divide the outside radical symbols, then you divide the inside radical symbols. Very much like multiplication. Let's take an example. Square root of 9 over 49. Notice both the numerator and denominator are underneath the radical symbol. This is actually the square root of 9, so we write that separately. This is actually the square root of 49, so we write that separately. We just separated them out. Now, square root of 9 is 3. The square root of 49 is 7. Next problem. Square root of 18 over 3. You cannot divide the 3 into the 18 and get 6, because this is not just 18. This is the square root of 18, and that's a different number. We're going to take this 18, and we're going to try to get two factors, where one's a perfect square, 9 times 2. That comes out to be 3, square root of 2, over 3. We cancel the 3's. Notice the 3 is multiplying the square root of 2. So the square root of 2 is the answer. On to the next. Square root of 54 over 6. We separated them out. We factored. 9 times 6 is 54. 9 is the perfect square. So we get 3 square root of 6 over square root of 6. And they cancel. And the answer is 3. Next problem. Oh, we have a note. The note is, you have the square root of 54 over 6. Instead of going here and separating them, since they are both numerator and denominator under the radical symbol, you can deal with this fraction together. So 54 divided by 6, all under the radical, is square root of 9, which comes out to be 3, the same answer. We're now going to talk about rationalizing the denominator. Your final answer should not have a radical symbol in the denominator. The same way we can't have a 0 in the denominator, you cannot have a radical symbol in the denominator. So we work the problem, same way as we did before. Separate the numerator, denominator, take the square root, and now we have as an answer in the denominator a radical symbol, which we cannot have. So in order to do rationalizing the denominator, you take whatever here and you multiply it by itself, and that will remove your radical symbol. The numerator is 5 times the square root of 7. Denominator, if you look at it, is 7 times 7 is 49, square root, and the square root of 49 is 7. The same number you had here. You really don't need to show this, because you will know that 7 times square root of 7 times the square root of 7 means you're taking the 7 out. Let's do another one. You'll see. We have the square root of 16 over 3. Work the problem. Square root of 16 is 4 over square root of 3. Now we can't have the square root here. So we take this and we multiply it by itself. Same thing. Not just the 3, but the square root of 3. So the numerator is 4, square root of 3. This would really multiply to be 9, and square root of that would be 3. Going on. We're going to rationalize the denominator. But now, instead of having monomial, we have a binomial. And what we are going to multiply it by is the exact same thing, but the opposite sign. Same 4, the same square root of 5, but the opposite sign. That will remove our middle term, which will really be removing the radicals. Now, these are called conjugates. It means it's the same exact numbers, but a different sign. So we come here, let's just look at the denominator first. If we work this problem here, we copy this and we copy this. We're going to do FOIL, just to show you. In a minute, I'm just going to tell you that you multiply right now the first and the last. Square root of 25 is 5. Notice there will be no square roots, no radical symbol at all. How did we do that? When we do FOIL, notice the inner is 4 times the square root of 5. The outer is going to be negative 4 square root of 5. That is going to give you the 0 always when you have the same terms, different signs. So therefore the radical symbols all went away. And here we're only going to have the number 11. So we work this, the numerator, we're going to do distributive property. So 3 times 4 is 12. And 3 times negative square root of 5. Remember there's a 1 here. You multiply outside first. 3 times the 1 is 3. And the square root of 5. And then we have over 11. And that's your answer. Let's try one more like this. Make sure everybody has it. Rationalizing the denominator. Binomial. What we're going to multiply both the numerator and denominator by are the same things in the denominator except a different sign. So we're going to multiply it by the square root of 3 minus 1. And we have to do the same in the numerator. Do the distributive property, and here it's the first and the last only because you know inner and outer will cancel each other. Excuse me. So we have 5 times the square root of 3. Remember, 5 times the 1 in the front, and 5 times negative 1 is negative 5. Here we have the square root of 3 times square root of 3, that's the first, is square root of 9. And the last is 1 plus times a negative 1 is a negative 1. Square root of 9 is 3, minus 1 is going to give us 2. So we have 5 square root of 3 minus 5 over 2. Final answer. And that is the end of this video.